Welcome to Pragim Technologies. I'm Venkat. This is part 39, Multicast Delegates. If you want to learn the basics around delegates, then I would strongly recommend you to watch parts 36, 37, and 38 of this video tutorial. In this session, we will be talking about multicast delegates. So, what is a multicast delegate? A multicast delegate is a delegate that has a references to more than one function, meaning a delegate that is pointing to more than one function. When you invoke a multicast delegate, all the functions the delegate is pointing to are invoked. Okay, let's look at an example and understand this better. So to create a delegate, we use the delegate keyword. So first let's go ahead and create a sample delegate. So let's say public delegate, and the return type of delegate is void, and let's call it as a sample delegate. And this delegate doesn't take any parameters. So we are creating a very simple delegate, okay, which has void return type and doesn't take any parameters. Now, we know that if we want this delegate to point to a function, that function needs to have the same signature, as this delegate. So let's go ahead and create that function. So let's say public void, and let's call this sample method 1. And all this function does is go ahead and prints a message to the console saying that sample method invoked. Okay, so if you look at what we have done until now, we have just created a delegate with void return type and no parameters, and we created another method, with void return type no parameter. The signatures match, so this delegate can point to this function. So how do we do that? We create an instance of this delegate, and to the constructor of the delegate we pass in the name of the function. And just a change, we will call the static function so that we don't have to create an instance of the Pragim class to invoke that function. So now we will create an instance of our sample delegate. Let's say delegate is equal to new sample delegate, and to the constructor we pass in the name of the function to which we want our delegate to be pointing to. So in this case, we want this delegate to point to this function. So we will copy that and we pass in that. So now if we go ahead and run this function, let's invoke the delegate. Okay, so if we go ahead and run this function now, what is going to happen? This delegate is invoked, and we know that this delegate is pointing to this function, so this method will be invoked. Okay, now how do we convert this delegate into a multicast delegate? Actually, there are two ways to do it. So we'll look at approach 1 first, and then we will later examine approach 2. In approach 1, what we will do is, instead of directly pointing to a method like this, we will create several instances of delegates. Let's say delegate 1, delegate 2, delegate 3, and maybe delegate 4 as well. Okay, from the definition, if you look at the slide, a multicast delegate is a delegate that has references or pointers to more than one function. So if a delegate points to more than one function, then it is called as a multicast delegate. Okay, so we want our delegate to be pointing to more than one function. So obviously we need to create more than one function which confirms to the signature of this delegate. So let's go ahead and copy this method and make 3 copies. So let's call the sample method 2, and the same is the message here, sample method 2 invoked, and sample method 3, and we will call the sample method 3 invoked. Okay, so we have 3 functions now, and if you look at all these 3 functions, their signature is the same as that of our delegate. So an instance of any instance of this delegate, del1, del2, del3, or del4, okay, any instance of the sample delegate can actually point to any of these methods. Now let's see how to do that. So what I'm doing is, we have sample delegate 1, so we will say delegate 1 is equal to new sample delegate, and we'll make that point to sample method 1, and similarly what we do, we make delegate 2 point to sample method 2 and delegate 3 point to sample method 3. Okay, so what we are doing here is assigning del1 to sample method 1, del2 to sample method 2, del3 to sample method 3. And now what we will do is we will make delegate 4 is equal to delegate 1 plus delegate 2 plus delegate 3. Okay, now there's a lot of code here, but if you understand it, it's pretty simple. What we are doing is we are making delegate 1 point to sample method 1, delegate 2 to sample method 2, and delegate 3 to sample method 3. And we're making delegate 4, you know, we are assigning delegate 4 with by adding all these three delegates together. What actually this does is, since delegate 1, delegate 2, and delegate 3 points to sample 1, sample 2, sample 3 respectively, and when you chain these delegates together using this plus sign and assign it to delegate 4, what you're doing effectively is your delegate 4 now is pointing to all of these three methods. So now if we go ahead and invoke delegate 4, what will happen is it will invoke all these three methods. So if I go ahead and run this, sample method 1 invoke, sample method 2 invoke, sample method 3 invoke. Now since this delegate now is pointing to three other functions, three different functions, this del4 is called as a multicast delegate. So now a delegate pointing to more than one function is called as a multicast delegate. Okay, and how do we make this delegate a multicast delegate? By chaining the delegates together with a plus sign. So if you want to chain delegates together, we use the plus sign. Actually, we can also use plus equals. We'll see that in just a bit. Okay, now let's say I don't want method 2 to be invoked, for example. Okay, now you can unchain or you can remove the references using the minus keyword. Now let's say when I do del2 minus del2, okay, so what we are effectively doing is we are adding delegate 2 and removing it. So effectively delegate 4 is now pointing to just delegate 1 and delegate 3, meaning it's pointing to sample method 1 and sample method 3, but not sample method 2 because we are removing it using the minus sign. So if we run this now, we will only see the output as sample method 1 invoked and sample method 3 invoked. Okay, so the point to keep in mind here is if you want to chain the delegates together, we use the plus sign. If you want to remove those, you use the minus sign. Okay, and what is a multicast delegate? A delegate that points to more than one function is called as multicast delegate. All right. So now there is another way to actually create a multicast delegate. You don't have to create so many instances. What you can actually do is, let's say I have a delegate del is equal to new sample delegate, and let's make this point to sample method 1. So now our delegate is pointing to sample method 1. Not only to that one, we can also say by using plus equal symbol, okay, this delegate now is pointing to one function, but I want this delegate to point to sample method 2 and sample method 3 as well. So how do we do that? We can use the plus equal sign with the same delegate instance. Okay, and then here you say sample method 2. What is happening here is we are using the plus equal sign to register this method with this delegate. Okay, so in the previous example we have seen we can use plus symbol when we use different instances of the delegate, but if you want to use the same instance and you still want your delegate to point to multiple functions, then you use plus equals, okay, to register. When we do this, when we use this syntax, what we are technically saying is we are registering this method with this delegate. And similarly, the same is the case if you pass it to the constructor, you are registering this delegate, this method with this delegate. Okay, so if you want to register the fourth method as well, the third method as well, you can do exactly the same thing. So sample method 3, and then if you go ahead and invoke the delegate now, it's going to invoke method 1, method 2, method 3. The same effect, but we are just using a slightly different approach to do this. Okay, so if you want to use the same instance and register multiple functions with this delegate, then we can use plus equals. If you want to make use of different instances, then you just use the plus sign. So you can either use plus, or if you go back to the slides, you can either use plus or plus equals to register a method with a delegate. Now when you register a method with the delegate, those methods are set to be in some kind of a list called as delegates invocation list. So when you invoke the delegate, okay, I mean specifically multicast delegate, a multicast delegate invokes the methods in its invocation list in the same order in which they are added. If you look at this one, we have added this in sample method 1, sample method 2, and sample method 3. So these functions will be invoked in that same order. And this is a multicast delegate. Why? Because it's pointing to more than one function right now. All right, and to remove a delegate, you can use minus equals. In the previous example, we have seen we used just the minus sign. Okay, so now it's like effectively our sample delegate. This delegate instance is pointing to just method 2 and 3, not method 1. So if I run this now, you will say method 2 invoked and method 3 invoked. So basically, to create a multicast delegate, you have two approaches, either using different instances of that delegate or using the same instance and then using plus equals to register and minus equals to unregister a function from a delegates invocation list. Okay, now there is a there is a small issue here. Now in our example, if you look at this methods, these are void methods, in the sense these methods doesn't return anything. And when you invoke the delegate, all of them will be called in that order in which they are registered. But now let's imagine if our function is going to return a value. Okay, if the function returns a value, then what's going to happen? Let's look at that. Let's say I have two functions. Now, first of all, if a function has to return a value, the function needs to have a return type. So I'm going to say this function is going to return an integer. And all this function does is return a number. So return, let's say 1. Since the return type of this function is integer, it's going to return 1. And same is the case here. This is going to return maybe 2. So this function is going to return 1 and this function is going to return 2. Now, if we want this delegate to be pointing to any of these functions, then this delegate signature has to match this function signature. So let's say the signature of the delegate, we have int return type. Okay. So now what we are doing is we are creating this delegate instance, and this delegate instance is pointing to sample method 1, and we are also registering sample method 2 with this delegate. And if you look at here, what we are doing is we are invoking this delegate, and when we invoke this delegate, what is the return type of this delegate? Integer, meaning this delegate is going to give us an integer back. Okay, so let's say int delegate returned value. Now if you look at what's happening here, this delegate now will go ahead and invoke this method and this method. When the delegate invokes this method, it will return 1. We get 1. When it invokes this method, we get 2. Okay, and we are saying, okay, whatever value is returned, store it in this value, in this variable. Now, do you think will 1 be returned or 2 be returned? Now, that's an interesting question. Okay, because a single variable cannot hold two values, and obviously if it's a multicast delegate and if the function returns a value, you can only harvest or you can only retrieve the value that is returned by the last function in the invocation list. So for this delegate, in its invocation list, we have two methods, method 1, method 2. Method 1 returns 1, method 2 returns 2, and method 2 is the last method in the invocation list. So this variable will hold value 2. Okay, so if we go ahead and print that now, console.writeLine, And if we just say delegate return value is equal to a placeholder and then a delegate return value, and if we run this program, you should say the return value is 2. That is returned by sample method 2. That is the last function in the invocation list. So if you look back the slides, if the delegate has a return type other than void, and if the delegate is a multicast delegate, only the value of the last invoked method will be returned. And along the same lines, if the delegate has an output parameter, then the value of the output parameter will be the value assigned by the last method. Let's look at an example to understand that better. Now let's say my delegate, my functions now are going to be void return type, but it's going to have an output parameter. So how do we have an output parameter? We use the out keyword. Again, if you're new to method parameters, there is a video session that I have recorded. Please check that video tutorial, if you're new to output parameters. Anyway, so output parameter int, and let's call this number. And what this function does is initialize that output parameter to a value. Let us say it initializes that to 1. And similarly, our sample method 2 is going to initialize that to 2. Okay. Now again, if we want our delegate to be pointing to these functions, obviously its signature has to conform to the signature of these methods. So let's change to do that. And this delegate takes in an output parameter of type integer, and let's call it as integer. Okay, now this delegate signature matches the signature of these methods, so this delegate can point to these functions. And obviously what we are doing here, excuse me, this delegate now is pointing to this method and this method, both of the methods. And if you look at this method, it initializes the output parameter to 1, and this method initializes it to 2. And now let's say, instead of saying delegate return value, let's call this output parameter value. Okay, and let's initialize that to -1. Now when we invoke this delegate, we know that we have to pass it an output parameter, which is going to be this one. So we're gonna say delegate, and it expects an output parameter to be passed in. So we use the out keyword and we pass in this variable, which will receive the value from these methods. So when we invoke this delegate, what it's going to do, it's going to obviously invoke this method and this method. This method initializes the number to 1, and this is initializing it to 2. But we can only get one value, and that value will be the value initialized by the last method. In our case, the last method is 2 in the invocation list of this delegate. So this method is initializing that to 2. So obviously this output parameter will receive the value of 2. And what we are doing here is we'll print that value. So if we run this now, you should say the delegate output parameter value is 2. So keep this in mind. This is very important. If the delegate has a return type other than void, and if the delegate is a multicast delegate, only the value of the last invoked method will be returned. And along the same lines, if the delegate has an output parameter, the value of the output parameter will be the value assigned by the last method in that invocation list of the delegate. And a very common interview question generally asked is, we know what a multicast delegate is. A multicast delegate is a delegate that points to more than one function. But what is the purpose? Where do we use these multicast delegates in reality? They are, these multicast delegates actually makes the implementation of observer design pattern very simple. Now, if you ask me, do we really have to use delegates to implement observer design pattern? No, you don't have to. But delegates makes it much easier. In fact, if you're using multicast delegates, you're indirectly using observer design pattern. However, we'll be talking about observer design pattern in detail in a later session. Okay, and also remember, this observer pattern is also called as publish subscribe pattern. These terms are actually used interchangeably. So these are the two examples that we have just seen. To create a multicast delegate, there are effectively two ways: either creating multiple instances or using the same instance. If you're creating multiple instances, you use the plus sign to chain the delegates together and minus sign to remove them. If you're using the same instance, you use plus equals to register a method and minus equal to unregister a method. That's it for today. Thank you for listening. Have a great day.